Hi students, in the last video we have discussed about the sampling process. Now we will discuss about the relationship between the analog frequency and digital frequency. So we know that x of n, that is a discrete time signal, is obtained by sampling the analog signal x of t at t equal to nts, where this time, that is analog signal, extends between minus infinity to infinity, and this Ts is the sampling period, we already discussed this, and Fs is the sampling rate, or it is a sampling frequency. And here we know that T equal to Nts. Here T we can write for Ts as 1 by Fs. So here we are going to obtain a relation between the analog frequency and the digital frequency. So for that I am considering a cos waveform, A cos ohm t plus phi. This ohm represent analog frequency. Now I am substituting t equal to nts. So substituting t equal to nts for this one. Okay. And now here we will represent discrete time signal with n. So I am grouping this ohm ts, this one, as omega. So omega is equal to ohm into ts. Now here omega is the digital frequency and this ohm is the analog frequency. So far, in order to differentiate the representation, I am considering small f for digital frequency and capital F for the analog frequency. Okay, so here this can be represented as, this is the angular frequency, so 2 pi f, which is equal to ohm into ts. So this ohm can be represented as ohm ts, and f is equal to, bringing this 2 pi, so we will consider this as a capital F, analog frequency. Okay, so we know that omega, that is analog frequency, is equal to 2 pi f. Okay, in order to differentiate digital and analog frequency, I am using capital notation here. Okay, then ts is equal to 1 by fs. So digital frequency is obtained by sampling the analog frequency, that is dividing the analog frequency by the sampling frequency. So this is what the relation between the analog and the digital frequency. So it is very important. We will use this in problems. Okay. Next is the range of frequency variable. Since it is an analog frequency, here it is extends from minus infinity to infinity, and digital frequency extends from minus pi to pi. And here this can be represented as, for omega we can substitute 2 pi, having f bringing by divided by 2 pi, so this also become again infinity. So this analog frequency rise in minus infinity to infinity, whereas discrete digital frequency omega, so we can put for omega here 2 pi f, 2 pi f. So when you put 2 pi f, pi will get cancelled. If I write only in terms of f, I will get minus 1 by 2 to 1 by 2. So this is represented in cycles per samples. Okay. Now take this. So omega is equal to, we know the relation between is omega is equal to ohm ts. So I am substituting this. Another thing, and also we know that this ohm, that is ohm, can be written as 2 pi f. For this ts I am substituting 1 by fs. So here that is cancelling these pi and bringing in the denominator to minus 1 by 2 less than f by fs less than 1 by 2 here. So now in order to obtain the sampling frequency, we need to have the relation that fs should be greater than or equal to 2f. Okay, so this is the condition why we are using twice the frequency for as a sampling frequency. I have discussed this in sampling concept. This is the reason why we are choosing fs is greater than or equal to 2f. Okay, so just this is what some of the basic concepts in sampling. Now we will see the problems in detail. Now, this is what considered an analog signal. Two analog signals are there. These are going to sample at a rate of fs is equal to 60 hertz. Now, I need to convert this analog signal into a discrete time signal. So, here, how we convert an analog signal into a discrete time signal? By substituting t equal to nts. So, I am writing the signal as such. So, this can be written as x1 of nts, which is nothing but x1 of n. So 2 cos 2 pi 20, instead of t I am going to write n into ts. Okay. So now this signal is converted into a discrete time signal. 2 cos 2 pi into 20 n. Here n comes, so it is a discrete time. But here we are not having ts, we are having only fs. So this can be written as 1 by fs. Okay. Therefore 2 cos 2 pi into 20 divided by 60 into n. So here 2 cos, so cancelling these terms you will get 2 pi by 3 into n. So here the digital signal, that is the discrete time signal x1 of n is equal to 2 cos 2 pi 3 by n for this x1 of t. Similarly, I am going to represent for x2 of t. x2 of nts can be written as x2 of n, so which is equal to 2 cos 2 pi into 8t into, instead of t I am going to substitute nts. So 2 cos 2 pi into 80 into n divided by fs. So 2 cos 2 pi into 80 divided by 60 into n. Okay. So here what I will get is, I will get 2 cos. So cancelling these three things. So this is 3. Okay. So you will get 8 pi n by 3. 2 cos 8 pi n by 3. Okay. And also there is another step. This can also be written as 2 cos 8 2 pi n by 3 plus 2 pi n. So when you take LCM, what you will get? You will get here 6 pi n. So when you add it, you will get 8 pi n. So this can be written as, this is a period. Okay. So this can be written as cos 2 pi n by 3. Okay. So when you sample these two signal, you will get this identical signal. Now consider the signal x of t is equal to sin pi t. We need to sample the given signal at a Nyquist rate. So here x of t equal to sin pi t. So this can be analogous to sin t. Omega t we will write it, since it is analog frequency I am representing t. So here which is equivalent to pi. So now I am having the frequency as pi. Okay, now I need to sample this. So how I will sample? I will substitute t equal to nts. So pi t equal to nts. Okay, so now here I have represented sin pi ts into n. Okay, so this is what the discrete time representation. Now I need to sample this signal with the time period of ts. So here I can find ts is equal to 1 by fs. Okay. So how we can find fs? Fs is nothing but, so here it should be satisfy the Nyquist criteria. So here I am having ohm. This should equal greater than or equal to, that is the sampling frequency, greater than or equal to twice the highest frequency component. So here highest frequency component is pi. Ohm is equal to pi. So here ohms is equal to 2 pi. Now this can be written as 2 pi fs, right? So here fs is equal to 1. So here the sampling frequency is 1. So I am substituting in this here. So 1 by 1. So sampling rate is 1. So here it is sin pi n. So this after converting this into a discrete time signal, I will get it at a that is x of n is equal to sin pi n. So the next problem is consider an analog signal x of t is equal to 2 cos 200 pi t plus 3 sin 100 pi t minus 4 sin 500 pi t. So here this signal is an summation of all these frequency component. Now first we need to find out the Nyquist rate. So if the you know that is the Nyquist rate, that is the sampling frequency is nothing but twice the highest frequency component. So that is twice the highest frequency. Okay, so here what we need to do is, here first we are having three different signal. So first we need to find three different angular. Just I am representing this, either you can write this in terms of frequency or angular component. Angular component is ohm. Okay, this is represent highest frequency component. Okay, either you can find out this or you can use this, that's up to you. So okay, now ohm 1 is equal to what? This one, right? 200 pi. Ohm 2 is equal to 100 pi and ohm 3 is equal to 500 pi. So here consider this, which is having the highest component. So ohm 3 is having the highest component. Therefore ohms is equal to twice into highest component. So 2 into 500 pi, which is equal to 1000 pi. Okay, now here from this I need to find out the fs, because if I want to find the x of n, what I need to do, I need to substitute t equal to nts, right? So here I need to find ts. So from this I am going to find ts. So 2 pi fs is equal to 1000 pi. So fs is equal to 500. So from this ts is equal to 1 by 500. Okay, now I am going to write this signal in terms of the by sampling t equal to nts. So after substituting t equal to nts, where ts is equal to 1 by 500 in this equation, I am getting this value. Now simplifying this, so I am getting x of n is equal to 2 cos 2 pi 2 pi 5 2 pi by 5 into n plus 3 sin, here it is n pi by 5 minus 4 sin pi n. So this is what the representation of this. Hope you have understand these concepts, sampling concept. I think you have understand all these problems. Okay, so we will see the next topic in the next video. Thank you.